ChatGPT o1 model now supports image uploads. I'm going to upload 10 challenging images to ChatGPT o1. Let's see what it says. My next image is from a lecture by Professor Hani Farid from UC Berkeley. So he's explaining this lecture, but he's also kind of explaining a Python code on the way, and he's also explaining a concept. So what I'm going to do is that I'm going to send this screenshot to ChatGPT, and I'm going to ask it if, so this is a screenshot of a lecture by Professor Hani Farid from UC Berkeley. And can you extract the text, and also can you explain what concept he's teaching? So the thing is that something like this is very useful to me because I've seen Professor Hani Farid's lecture, and then since the text is embedded inside, it's kind of it's good to understand what he's teaching, but at the same time, I would be like, okay, what would be great if I can just copy the text and then do it. So let's see if it can first copy the text. So it says the first one is it's copied it very well, and then the one next is the model. So it's done that one also. It's extracted very well. And then it has the quadratic form, and then the steepest descent. And then while true, so it has this, and all of those things. So let's see if it's able to explain the concept. I mean, that's the interesting thing about o1, right? Like, it's not just a thing. So since the code is a demonstration of an iterative optimization method, that is correct. That is amazing. Now I finally am happy with o1. To solve a linear regression problem, here's what happening step by step. It is iterative optimization, so that is amazing. Like, so it says the code first generates a simple linear model, then YMC are shown. Random data points X, Y are created according to that line. Linear regression in matrix form, so it has like after defining X and Y, data is arranged in a matrix, and each row corresponds to a data point, and the columns indicate the X values. Okay, the goal of linear regression is to find parameters U that minimize the square. That is correct. In the predicted XQ and the observed Y, so that is also correct. So the quadratic, the least squares quadratic form is minimize the U such that XU minus Y the whole squared. For this we derive A equals X transpose X and B equals X transpose Y. That is also correct. And the optimal view in a closed form solution is given by this. And let's see, this is the most important part, right? Which type of steepest descent, if it's able to get this. So instead of solving by a matrix inversion, that is amazing, because anybody, the basic thing in linear algebra, like Hilbert-Schrank's course, would be like you would do either a matrix inversion or you do the pseudo inverse. So it's great that it's actually able to go to this extent. Computing the residual Ri equals B minus AUI, which points in the direction of greatest decrease in error. That is correct. Determining a step size AI that optimally scales the update. That is also correct. And then updating Uj equals Ui plus AIRI. So in summary, Professor Farid is teaching how to solve a linear regression using a numerical optimization steepest descent rather than directly computing the closed form solution. This concept is a fundamental demonstration of gradient-based optimization methods in machine learning and numerical analysis, and shows an iterative approach converges to the least squares approach. I am totally floored by this. This is what I would be expecting a reasoning model to do. So, and this is the I've gone through these lectures, and Professor Farid is explaining that, and the interesting thing is that this would actually help me. I would want to kind of also like I would usually copy paste this and then do that, and then instead of copy, I will just literally copy them and be doing that. Now instead of this, if GPT can actually extract this text and also explain these concepts in such an amazing way, this is something what I was hoping for from o1. And I think out of all the answers I had so far, this one is the best and the one that am most happy with. So excellent, so happy. I should give it maybe with 2 points, but let me just stop it with 1.